With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, a hollow copper sphere and a hollow copper cube of same surface area and negligible thickness are filled with warm water of same temperature. So if you see, the sphere and the cube are made up of copper, surface area is same and thickness is negligible, and they both are at same temperature, placed in an enclosure of constant temperature few degree below that the body. Then in the beginning you have to check out of ABCD which option is the correct one. So basically rate of energy loss you have to check first, and then rate of fall of temperature you have to check. Rate of fall of temperature. So if I talk about rate of fall of temperature and or rate of energy loss, so that will be because of the exposure to the atmosphere, and from the Stephens-Boltzmann law we know that it will depends on the body temperature and the surrounding temperature. So they both are at same temperature, let's say T0 and T0, and surrounding temperature it is said it is little less, like this. So if I talk about the rate of heat loss, that will be same in the two, right? It will be what? It will be sigma times surface area, right, and emissivity, and since they both are made up of copper, right, and it will be temperature of the body to the T to the power 4. So the all the expression is same for the two, right? All the expression is same for the two. So it will be this for the two. The rate with which energy will be radiated out of the body to the atmosphere, to the surrounding, it is this, right? Now the rate of fall of temperature of the sphere is less than that of the cube. So if I talk about the rate of fall of temperature, right, for that you have to see like out of these two which is having more mass or less mass. So if I talk about the heat taken, it is ms dt. So if you divide both side by small temperature this, so we are talking about the fall of temperature. So fall of temperature dt by dt is equals to dq by dt, which is same for the two in division this. So if I write down the rate of fall of temperature, so this quantity is same for the two. So if I say this as h, so h is same for the two, right? So which is varying here? Which quantity is varying here? Mass is varying. So we'll write down the fall of temperature is inversely related with the mass. Now if you see here, this is the radius r and this is the side length a, and both have same surface area. If you see, the surface area is said it is same surface area. So how could they have the same surface area? You have to compare the radius and the side length. So if you see, the surface area here it is 6a square. Now the two are filled with water. So how much water they two have, right? For that, let us calculate the ratio of R and A. So if you see R by A, it will be 6 by 4 pi to the power half, right? 6 by 4 pi to the power half. So if I calculate the volume of the water that is inside them, it is volume of the sphere by volume of the cube. So volume of the sphere is 4 pi by 3, and this is a cube, right? So if you put the value here, 4 pi by 3, it is 6 by 4 pi 3 by 2. So if you see, here is the power 3 by 2, so I will write down it as 4 pi by 3, 4 pi by 3 into 6 by 4 pi, 6 by 4 pi power half. So this will get cancelled out and this will be cancelled out. So if you see here, this is 3 by 2. right? So if you take this 4 inside, this is 2 inside, so it will be 12 by 2 pi to the power half, so it is 6 by pi to the power half. So certainly if you see the volume of this sphere is more than, if you see here, this is more than the volume of the cube, right? So the one which is having more volume will have more water inside that, right? So more water is halved by this sphere, so the rate of fall of temperature will be inversely proportional to that. You can see it, you can also see that this rate of fall of temperature is inversely related with the volume inside that. And as we have compared, you can see the velocity, the volume of the sphere, the volume inside the sphere is more than the volume inside the cube. So if you see here, the rate of fall of temperature is less than that of the cube. So yes, this is true because the sphere have more volume inside that. So the one which have more volume of water inside the container will, the fall of the temperature for that will be less. So as you can see, B and D are the correct one. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.